Welcome back. Today we're going to go over writing expressions. So first off, we need to review a lot of different ways that we can say the operations as far as in words when looking at story problems, and some of their synonyms that we can look for. So first off, with addition, there are a lot of different words that could mean addition. But first off, more than is something that means addition, increased by, some, which you should be most familiar with, gain, greater than, and notice it doesn't say is greater than, it just says greater than. Then altogether, total, and in all. Combine, those make up what we would consider words that are for addition, and those are keywords that we look at, especially in story problems or short answer problems. Those help us understand what it's specifically looking for. For subtraction, we have fewer, difference, loss, decreased by, less than, and again notice that it doesn't say is less than. This is different than is less than. It has to say the words less than. For multiplication, we have product, times, each, per, twice. For division, we have quotient, divided by, split, half, shared equally. Now there are some weird ones in there, but each of those should kind of help you see what we're doing. And then equals, we have is and same. Okay, so using those pieces of information, we're going to break apart some problems and see if we can't get each piece in there. So first off, expressions, they're verbal statements. They can be translated to algebraic expressions. It's like deciphering a secret message or translating from one language to another. So just like you would say in one language, math is a language, and so when we're talking about algebra, algebra is a language. And in this language, the expressions in the mathematical phrases, they contain numbers, variables, and operations. It does not contain an equal sign, so that's the major difference between expression and equations. You cannot have an equal sign for it to remain an expression. So here we are labeling parts of an expression, and in these parts, the very basic pieces, we have a variable, we have an operation, which is a subtraction sign this time, so that's our operation. We also have a constant. That 9 will never change. It's always going to stay a 9. When we simplify it, it goes away, yes, but in this problem, the way it is right now, that is called a constant because it does not change, and that's why this one's called a variable, because it depends on what it is. And then we have the coefficient. That is a number that's in front of a variable. Each problem will have terms in them. A term is separated by a plus or minus sign or an operation. So this operation right here separates the term 4D and the term 9. So this is also a term and a constant. They're just describing two different things. So we have this term here and that term there. If there's one operation, that means there are two terms. If there's two operations, that means there's three terms, and so forth. Now, the entire thing altogether, that would be called an expression. And that's because there is no equal sign. Alright, so using that information, here we have 8 more than a number. So we want to write an algebraic expression that represents this verbal expression, 8 more than a number. So I start off with more than. The math operation that is more than, according to our words that we went through, would be plus. And then we have 8 and a number. So I go ahead and say plus 8 because it says 8 more. This means 8 more. Than a number, I go ahead and put a variable. Number 2, the difference between a number and 5. So we have the difference and then a number and 5. So difference is subtraction, and I go ahead and put a number and 5. Notice how I didn't put this number variable second. That has to be first because it's in the order. Whenever we see difference, it's the order that's here. Number and 5, number and 5. Number 3, 19 added to a number. Well, that's kind of simple. It's just adding. So I go ahead and say that we're adding 19. So that's why I have to say x plus 19. Right, so it says here, write an algebraic expression to represent the verbal expression 6 less than n. Notice it doesn't say 6 is less than, it just says 6 less than. So we take whatever it is and get 6 less. To show 6 less, I have to go ahead and say subtract 6. And then I just put my variable, n. Number 5, the difference of 10 and q. So difference is subtraction again. In subtraction we use the order that's there. So that would be 10 minus q. Number 6, 19 added to j. So I go ahead and write that out. 19 is added. So that's going to be j plus 19 because we're adding 19. We're not adding j. It's 19 added. Okay, so we're adding 19. Number 7, 14 increased by b. Now that's a specific order. So it says 14 is increased, and it is increased by the variable b. That's why b is second. Then we have here k less 7. Now it doesn't say less than, it says k less 7. So that means we take k and we get rid of 7. Number 9, 12 less than p. So that means we take p and we want 12 less. So we would say p subtract 12. Number 10, the sum of g and 11. So sum, that tells me it's addition. G and 11, it tells me the order. So g plus 11. Number 11, decreased by, and we have t is decreased by 3. So it's decreased by 3. That means that I take t and I get rid of 3. So that would be t minus 3. Right. Multiplication is written side by side with the coefficient in front of the variable. So if we have here the product of 9 and n, product means multiplication, so that just means I put 9n. 9 times n. Q times 12, that would be 12q. Twice a number n, so that'd be 2n. 16 multiplied by j, so it's 16j. In addition to that, with division, we have to use the divisor and the dividend. So if we say k divided by 10, we go ahead and say k divided by 10 in fraction form. The quotient of x and 6, so that would be x divided by 6. 9 divided by c, so that's 9 divided by c. The quotient of 4 and q, so that would be 4 divided by q. For equations, they show that the expression is equal to another expression. It contains an equal sign. So we basically do the exact same thing we've been doing, but we have an equal sign and another expression on the other side. So in this one, we're going to write an expression or an equation based on the information. So first off, number 1, 4 times a w is 18. A key word here, if it has the word is next to two separate things, that means it has to be an equal sign. So I start with my equal sign, and I say 4 times w equals, and then the other side, 18. So I have the expression 4w and the expression 18. When they're separated by an equal sign, this becomes an equation. Number 2, n divided by 7. So I take n and I divide it by 7. That is an expression because there is no equal sign. Number 3, 1/3 the sum of 11 and p. So I have to take 1/3 of the sum of 11 and p. So first off, I have to take the sum of 11 and p. So I do that. I say the sum of 11 and p, and I want 1/3 of whatever that answer is, so I have to change the order of operations by adding parentheses and 1/3 on the outside. This means 1/3 the sum of 11 and p. Number 4, 14 is half of g. So is, that tells me there's an equal sign, and I would just put 14 and then half of g on the other side. So 14 and 1/2 times g, or 14 equals g divided by 2. Those are identical. Number 5, the product of r and 9 is 45. So we have the product is, so that tells me that we're going to have r and 9, which is 9r, is 45. And that becomes an equation. Number 6, the difference between 5 and b. So difference is subtraction, and the order matters, which it looks maybe I skipped to number 7. I must have skipped number 6. So the quotient of s and 8, and then we have here the quotient of m and 5 plus 9. So we say the quotient of m and 5, that means m divided by 5, and then we're going to add 9 to that. So it looks like number 6 is a bonus. Go ahead and answer that, and hopefully this was helpful for you. Have a great day.